Hello, this is Mr. Brooks, and welcome to Lesson 8.2, Special Right Triangles. In this lesson, we're going to learn the properties of a 45-45-90 triangle, and we're going to learn properties of 30-60-90 triangles. And when I say 30-60-90, I mean 30 degrees, 60 degrees, 90 degree triangles. And we're going to find the distance from home plate to second base on a softball diamond. First, let us begin by looking at an isosceles right triangle. Hopefully you agree that in an isosceles right triangle, both of your base angles are 45 degrees. So this is also known as a 45-45-90. An isosceles right triangle is also a 45-45-90. Now, let's see if we can get a relationship between the length of the legs and the length of the hypotenuse for a 45-45-90. Well, as we learned in the last lesson, a squared plus b squared equals c squared. So x squared plus x squared has got to equal y squared. Combine your like terms, 2x squared equals y squared. Take square root of both sides. Square root of y squared is y. This would be the square root of 2 times the square root of x squared. Well, the square root of x squared is just x times the square root of 2 equals y. So y equals x times the square root of 2. So if you know the length of a leg of a 45-45-90, you multiply it by the square root of 2 to get the length of the hypotenuse, which is exactly what Theorem 8.5 tells us. Multiply the length of a leg of a 45-45-90 by the square root of 2 to get the length of the hypotenuse. Okay, let's look at some examples and try see if we can figure out the length of the hypotenuse. Well, in example A, again we said multiply the length of the leg by the square root of 2. So hopefully you would agree h, the length of the hypotenuse, is going to equal 9 times the square root of 2. That's the length of the hypotenuse for part A. In B, you're going to multiply the length of the leg, which is 2 times the square root of 2, by the square root of 2 to get x, which is the length of the hypotenuse. Square root of 2 times square root of 2 is the square root of 4, so you have 2 times 2, which is 4. So the answer to part B is 4. In quick check number 1, it tells us, again, we've got a 45-45-90, which is an isosceles right triangle, which I have drawn, with the length of the leg 5 times the square root of 3. Please pause the video while you try to get the length of the hypotenuse. Again, we're going to take 5 times the square root of 3, the length of the leg, and multiply it by the square root of 2. So we get 5 times the square root of 6 for the length of the hypotenuse. And since you cannot simplify that, that is our final answer. Now in example 2, this time they give us the hypotenuse and ask us to find the length of the leg. Well, hopefully, if we have to multiply the leg by the square root of 2 to get the length of the hypotenuse, hopefully you would agree you're going to divide the length of the hypotenuse by the square root of 2 to get the length of the leg. And of course, we cannot have radicals in the denominator, so we're going to multiply by the square root of 2 over the square root of 2 to get the radical out of the denominator. So this gives us on top 6 times the square root of 2. On the bottom, you get the square root of 4. So you get 6 times the square root of 2 all over 2. So your final answer is 3 times the square root of 2. Quick check number 2 says we have a 45-45-90, an isosceles right triangle, with a hypotenuse of length 10. How are we going to get the length of the leg? Please pause the video while you try to figure this out. Well, I like drawing pictures, so we're given the hypotenuse 10. We're trying to get the length of the leg. Well, if you got to multiply the length of the leg by the square root of 2 to get the hypotenuse, again, you're going to divide the hypotenuse by the square root of 2 to get the length of the leg. Now, since we've got a radical in the denominator, we've got to multiply by the square root of 2 over the square root of 2. We've got to multiply by 1 whenever you have a radical in the denominator. So on top, we get 10 times the square root of 2 all over the square root of 4. So you get 10 times the square root of 2 all over 2. So your final answer is 5 times the square root of 2 for the length of the leg. Example 3 asks us, you have got a high school softball diamond, which is basically just a big square, where the distance between the bases is 60 feet. And wants to know how far is the catcher throwing the ball from home to second to the nearest foot. So they've given us a figure. Please pause the video while you try to figure this out. Again, I have redrawn the figure, taken part of the triangle, part of the softball diamond, and turned it, half of it, which is a triangle, and the legs are 60. What's the length of the hypotenuse? So we're going to take length of the leg times the square root of 2 to get the length of the hypotenuse. So the distance from home to second is simply going to be 60 times the square root of 2. And as we learned in the previous video, that really doesn't tell me how far it is from home to second. It's 60 times the square root of 2 feet. That's why we said in the example of the distance between the two dots, you actually want to use your calculator and punch in 60 times the square root of 2 so you can get an answer that actually means something to somebody. And that would tell you it's approximately 84.8 feet. So it's about 85 feet from home to second base in high school softball. Quick check number 3 says, you have a square garden where each side is 100 feet long. You want to build a brick path along the diagonal of the square. How long will the path be to the nearest foot? Please pause the video while you try to figure this out. Okay, here we have our square garden and our brick path down the middle. You like how I made the garden green and the brick path red? Okay, so we've got to get the length of the diagonal of, again, a 45, 45, 90. So we're simply going to take length of the leg and multiply it by the square root of 2 to get the length of the hypotenuse. So in simplest radical form, it's going to be 100 times the square root of 2, which when we plug that into our calculator, we're going to get approximately 141 feet for the length of the brick path. The second half of the lesson talks about 30, 60, 90 triangles. If you have a 30, 60, 90 triangle, there are 2 rules you need to know to figure out the length of the legs and the hypotenuse. First rule is, if you know, again, the shorter leg is the key to getting the other 2 sides. If you know the shorter leg, you multiply it by 2 to get the length of the hypotenuse. If you know the shorter leg, you multiply it by the square root of 3 to get the length of the longer leg. Now let's take a look at some examples and see if we can figure out the missing sides. Okay, let's look at this 30, 60, 90 triangle and see if we can get the length of the longer leg and the length of the hypotenuse. We're given the shorter leg. Again, the shorter leg will always be opposite the smallest angle. So 4 is our shorter leg. So we multiply by 2 to get the hypotenuse. So the hypotenuse is going to be 8. The length of the longer leg is going to be 4 times the square root of 3. Hopefully that makes sense to you. If you get the shorter leg, multiply it by 2 to get the hypotenuse. If you know the shorter leg, multiply it by the square root of 3 to get the length of the longer leg. In example 4, we're given the length of the longer leg. We've got to get the length of the shorter leg, D, and the length of the hypotenuse. Well, like I said, the shorter leg is the key. You must get the shorter leg first before you get the hypotenuse. So if we multiply the shorter leg by 2 to get, if we multiply the shorter leg by the square root of 3 to get the longer leg, you're going to have to take the longer leg, which in this case is 5, and divide it by the square root of 3 to get the length of the shorter leg. Now again, we can't leave a radical in the denominator, so we're going to multiply by the square root of 3 over the square root of 3, which gives us 5 times the square root of 3 all over the square root of 9. I'm going to start skipping that step and just write 5 times the square root of 3 all over 3. That's the length of the shorter leg. That equals D. Now how do you get the length of the hypotenuse? Multiply the shorter leg by 2 to get the length of the hypotenuse. So F is going to be 2 times 5 times the square root of 3 all over 3, which will give us 10 times the square root of 3 all over 3 for the length of the hypotenuse. Example 4 gives us a 30, 60, 90 triangle and gives us the hypotenuse. How are you going to get the length of the shorter leg and the length of the longer leg? Please pause the video while you try to figure this out. Well, since the length of the hypotenuse is 8, and again, the key is the shorter leg. You have to get the shorter leg first each time. So we're going to take 8 and divide it by 2 to get x. So x is going to equal 4. Now y is going to be the shorter leg times the square root of 3. So y is simply 4 times the square root of 3. Example 5 asks us to find the length of each edge of the moose warning sign if the height of the moose warning sign is 1 meter. Okay, so obviously this is a very big sign if it's 1 meter tall. Moose is a very big animal, and you don't want to be hitting those with your vehicle. I mean, think of the damage that a deer does around here to our cars. Moose would be considerably worse since they're so much bigger. So, if the height of the moose warning sign is 1 meter, what's the length of each edge? Well, since it tells us the moose warning sign is an equilateral triangle, again, I've taken half of it, which creates a 30, 60, 90 triangle. So, first we're going to get the bottom side of the triangle, then we'll multiply it by 2 to get the length of the leg. So, x is going to be 1 divided by the square root of 3. Remember, you multiply the shorter leg by the square root of 3 to get the longer leg, so we're going to divide by the square root of 3 to get the shorter leg. So, you can't have a radical in the denominator. We're going to multiply by the square root of 3 over the square root of 3, and we get the square root of 3 over 3 for the shorter leg of our 30, 60, 90. Then, as we said, we're going to multiply it by 2 to get the length of the hypotenuse, which is the edge of the sign. So this is going to be 2 times the square root of 3 all over 3. And again, that really doesn't tell us how long the edge of the sign is, so it would be better to turn that into an approximate answer, which we plug that into our calculator, and we get approximately 1.155 meters. Each edge of the moose warning sign is just under 1.2 meters long. And our last quick check for this lesson says, if the edges of the moose warning sign are 1 meter long, what's the height going to be? So please pause the video while you try to figure this out. So again, we've got our moose warning sign where each edge of the sign is 1 meter. What's the height going to be? Well, first thing I'm going to do is redraw part of the triangle. Again, it was an equilateral triangle, so this is going to be a 30, 60, 90. Alright, with each edge being 1. Well, you've got to divide by 2 to get the length of the shorter leg of a 30, 60, 90. So this is going to be a half a meter. Then you multiply by the square root of 3 to get the longer leg. So it's going to be 1/2 times the square root of 3. Or you could just say square root of 3 all over 2. And then that doesn't really tell us how high the sign is. So you're going to plug that into your calculator, square root of 3 all over 2, and make sure you use the parentheses when you plug that in. And you're going to get approximately 0.9 meters is the height, height of the sign, excuse me. And this concludes lesson 8.2.